Hello, this is Mr. Huber. In this video, I'm going to go through the answer key for the unit circle and special trig values timed Schoology quiz. You got a reminder, these might not be the same order you saw the questions because they randomized, but these are the same questions you would have seen at some point during the quiz. So we'll go through. You can obviously pause, rewind, watch, follow up with me if you have further questions, but I'll just progress through these at a pretty decent pace so you can see what the correct answers would be and some explanation for them as well. All right, number one said given theta is 230 degrees, find alpha. So we just do 230 minus 180 and the reference angle would be 50 degrees. For number two, given sine is negative 5/13 in quadrant 4. So a quick sketch of this maybe if it helps. All right, so sine is y over r. So it means our y value 5, r is 13. Okay, and so we would need an x value here to find tangent because tangent is y over x. So we could set up with our right triangle here and find x is 12. We want to keep in mind this point here would be 12 comma negative 5. Right, we're in the fourth quadrant, so we have a negative y value. All right, so when we set up tangent as y over x, we'd have negative 5/12. All right, for tangent greater than 0 in quadrant 3 because, and there are some options you could pick from, the correct one was tangent is y over x, and both values are negative in quadrant 3. All right, if we talk about quadrant 3 over here, we have any point in this quadrant, we'd have a negative x and a negative y. As we saw in the last problem, tangent's y over x, so if we have a negative over a negative, it will equal a positive. So that's why tangent is positive in quadrant 3. Greater than 0 means positive because both y and x are negative. And when you write a ratio with a negative over a negative, it comes out positive. Okay, so let's go on here. Number 4. All right, it says in the unit circle, given that sine of theta is 0.9135, when the radius is 2, sine theta would be the same. 0.9135. The whole point of the unit circle is it doesn't matter what the radius is. So we use a unit circle to get ratios for sine, cosine, and tangent because they'd be the same ratios no matter what the radius is. Okay, so if I draw this out, if I have, let's say the unit circle here, I'll kind of put in red, and if I did a radius of 2 around it, okay, it really wouldn't matter if I drew an angle out here and went through this point on the unit circle, this point on the radius of 2, right? The ratio is going to be the same for sine, cosine, tangent, whether I draw a triangle down like this or down like this, right? My ratios are going to be the same. Sine would be opposite over hypotenuse when we talk about a right triangle, or in this case y over r, more importantly. The y over r ratio is going to come out the same for both those. That's the whole point of it. When you use a calculator, it doesn't know if you're using a unit circle or what circle you're using. It knows the ratio. So we use a unit circle and everything's based the same from that. All right, so similar in this next question, whenever the reference angle is the same, each trig ratio will be the same. Doesn't matter what quadrant we're in. If we have a reference angle of 30 degrees in quadrant 1 or quadrant 2 or 3 or 4, the trig ratio will be the same. It'll just change whether it's positive or negative in the different quadrants. Okay, so when a reference angle is the same, each trig ratio will be the same. That is one of the biggest things you can know from this material that we're working on, is when the reference angle is the same, the trig ratio will be the same, which is why we talk about understand quadrant 1 and you understand the whole unit circle. All right, here we have what are the coordinates of a point where an angle of 150 degrees in standard position intercepts the unit circle. So 150 degrees would be out here. All right, the big key to that is that it would be a reference angle of 30 degrees. Okay, so in a reference angle of 30 degrees, this is going to be the 1/2. This is going to be square root of 3/2. And the coordinates for that point, then we have to make sure we know we would have a negative square root of 3/2 and a positive 1/2. Okay, that reference angle of 30 degrees is going to have the same y and x values in any quadrant. Right? If we draw out that 30, 60, 90 triangle in quadrant 1 with a radius of 1 in the unit circle, short leg is 1/2. It's half the hypotenuse, and then times the square root of 3 to get that other longer leg. Right? It's the same ratios for that other reference triangle with a 30-degree reference angle with 150-degree theta. This is 150 degrees. Right, we'd have the same reference angle, we'd have the same ratio, and we'd have the coordinates for that point. We have to make sure we know where we have positives and negatives. In quadrant 2, we'd have a negative x and a positive y. All right, let's go to number 7 here, the next question we saw. And what I'm going to do on the top here, really you only need to draw 2 triangles, maybe 3. So I'm going to draw a 30-degree reference angle, and we just saw that. Okay, a 45-degree reference angle. So if we have 45 degrees here in our right triangle, and a radius of 1, we're going to have square root of 2 over 2, and the 2 legs are the same, square root of 2 over 2. Keep in mind, that would be because we divide by the square root of 2 to get the leg, and then you have to rationalize the denominator. And then if you want to draw a 60-degree reference angle, that's fine. It doesn't really matter. You shouldn't really need to. It's the same as the 30, 60, 90, just flipped, okay? Here, this would be the 1/2 and the square root of 3 over 2, because the short leg and the long leg are switched. We talked about that. That's all you need, right? You can use that. As long as you know the reference angle, then you can use these ratios. So find the exact value of the trig function, cosine 210. So now we didn't know that cosine, okay, is x over r, and 210 is a reference angle of 30 degrees in quadrant 3. Okay, so the quadrants can help us make sure we get the sign right. Okay, all students take calculus, so quadrant 3, cosine should be negative because you're going to have a negative x value in quadrant 3. All right, so 30-degree reference angle, cosine. Again, I can just use this right here. Right, it's a 30-degree reference angle. So the x value is square root of 3 over 2. And remember that over 1, square root of 3 over 2 over 1 is just square root of 3 over 2. We have a negative. So negative square root of 3 over 2. All right? Exact trig value of 180 degrees. This is a special case one. So 180 degrees is over here. That's negative 1 comma 0. And the radius is always 1 in the unit circle. We can use sine is y over r. So my y value is 0 over r will just come out to 0. Okay, so 0 would be my answer for sine of 180 degrees. 300 degrees, okay, that's a reference angle of 60, and it's in quadrant 4. Okay, tangent is y over x. So a 60-degree reference angle, that's that green one there up at the top, right? The 60-degree reference angle, right up here, 60-degree reference angle. So we're going to have a y value of square root of 3 over 2 over 1/2. We need to do a little bit of work here. This is square root of 3 over 2 times 2 over 1, because dividing by a fraction, same as multiplying by its reciprocal. Just cancel, you get square root of 3. And we want to make sure we know what quadrant we're in, because it would be easy to say square root of 3 as our final answer, but tangent in quadrant 4 is negative. Okay, so we'd have negative square root of 3. Then we could go to these next couple here. So negative 315 degrees, okay? That is a reference angle of 45 degrees. So our reference angle is 45 degrees. Negative 315 is in quadrant 1, so we're going to have a positive answer because we're in quadrant 1. All the trig functions are positive there. And that's a 45-degree reference angle. That triangle we had up here, I can go back to it. All right, that's the one in red, 45-degree reference angle. X and Y are both square root of 2 over 2. Okay, so our answer for this would be square root of 2 over 2. All right. And the exact trig value for 495 degrees. So you could subtract 360 from this. Subtract 360. It's 135 degrees. Okay, that's a reference angle of 45 degrees, and it's in quadrant 2. Okay, and tangent we're doing as y over x. So in a 45-degree reference angle, we have square root of 2 over 2 for the y and the x. So when the y and the x are the same, that's going to be equal to 1. Okay, we are in quadrant 2 where tangent's negative, so negative 1. Because we'd have a negative x and a positive y in quadrant 2. So again, that's why that would always work. That's why the all students take calculus works. It helps us know what's positive and negative in different quadrants. And then the last question, why is the ratio for sine always equal to the y-coordinate of the point where the angle intercepts the unit circle. We've talked about that through some of these last problems, okay? Sine is y over r, and the r value is always 1. So if you put y over 1, it'll always be equal to y. That's why, again, if we just had any point, right, let's go back to 150 degrees, excuse me, 150 degrees, okay? We had the point right there, right, with our 30-degree reference angle. Okay, this point was negative square root of 3 over 2, comma 1/2. So if you say sine, that's y over r, that's y 1/2 over r is 1. That's going to come out to 1/2. It's always going to be the same as the y value. The y value is always going to be the sine ratio. The x value is always going to be the cosine ratio because you put it over 1 and it doesn't change. It stays the same. All right, so there's a run through of the different problems and the answers and a little bit of explanation along the way. If that helped, if there's still areas you're having difficulty with or problems you're unsure about, make sure you're contacting me and follow up and make sure you're understanding this material. Again, understand those trig ratios for the special angle values. When you have a 30, a 45, or a 60-degree reference angle, know those three, how quadrant 1 plays all the way around to all the different quadrants.